Bphct 131 Mechanics Block 1 Mathematical Preliminaries Unit 1 Vector Algebra 1 Unit 2 Vector Algebra 2 Unit 3 First Order Ordinary Differential Equations Unit 4 Second Order Ordinary Differential Equations with Constant Coefficients Appendix Basic Concept of Calculus Contents Mechanics Course Introduction Block 1 Mathematical Preliminaries Unit 1 Vector Algebra 1 Introduction Scalar and Vectors Scalars Vectors Equality of Vectors Unit Vectors and Null Vectors Vector Algebra Addition of vectors, subtraction of vectors, products of vectors, scalar product, vector product, summary, terminal question, solution and answer. Vector algebra 2, introduction, vector components in the Cartesian coordinate system, unit vectors in the Cartesian coordinate system, representing a vector in terms of its components, scalar and vector products in component form, scalar product in component form, vector product in component form, vector functions, defining vector functions, derivative of a vector functions, summary, terminal questions, solution and answer. First order ordinary differential equations. Introduction, classification and solution of ODEs. Further classification of first order ODEs. General solution and particular solutions. Separable first order ODEs. Method of separation of variables. Method of substitution. First order homogeneous ODEs. First order exact ODEs. First order non-homogeneous ODEs. Summary, terminal questions, solution and answer. Appendix on partial derivatives. Unit 4. Second order ordinary differential equations with constant coefficients. Introduction. Some terminology. Linear independent solution and the Wronskian method of exponential function. Real and distinct roots. Real and equal roots. Complex roots. Summary, terminal question, solution and answer. Appendix, basic concept of calculus, the concept of derivative, the concept of an integral. Table of physical constant, list of blocks and units, BPACT 131, syllabus mechanics, BPACT 131. Mechanics course introduction. In our everyday life, we come across a wide variety of objects in motion. The branch of physics dealing with the motion of bodies and bodies at rest in equilibrium is called mechanics. You use the laws of mechanics when you ride a bicycle, lift heavy loads, play football or build a house. Many fascinating developments of the space age, such as launching of space probes and artificial satellites, are direct applications of the laws of mechanics. Where do we use the laws of mechanics? Today, mechanics is regarded as the most fundamental areas of physics. In order to study other areas of physics such as waves, thermal physics, electromagnetism, optics, etc., you need to have a sound knowledge of mechanics. Therefore, mechanics is being affirmed as the very first course in physics in BSc in this 4-credit course. You will learn the basic concept and laws of mechanics in detail and apply them to objects in motion. We will discuss translational motion, angular or rotational motion, and oscillatory or vibrational motion of a variety of objects. The course consists of 4 blocks. You have studied many of these concepts in your school physics courses. You know that the concept and laws in physics are expressed very efficiently in the language of mathematics. Therefore, in block 1 of this course entitled Mathematical Preliminaries, we explain the preliminary concept of mathematics needed for studied mechanics. In this block, you will study the elementary concept of vector algebra and learn how to differentiate vector functions with respect to a scalar. You will also learn how to solve first and second order ordinary differential equations. In block 2, entitled Basic Concept of Mechanics, you will revise the concept of kinematics and dynamics that you have studied in school physics. This includes Newton's laws of motion and the concept of force, linear momentum, impulse, work, and energy. Here we will present them in greater detail and apply these laws and concepts to a variety of simple physical situations involving translational motions of objects. For example, you will study the motion of a parachute falling under the force of gravity and air resistance, the motion of a cart or box being pulled up or pushed down on an inclined plane or on the floor under the force of friction, the change in the velocity of a rocket as gas is ejected from it, and so on. Block 3, entitled Rotational Motions and Many Particle Systems, deals with the concept of angular or rotational motions, torque, and angular momentum, as well as the three important conservation laws of linear momentum, energy, and angular momentum. We apply all these concepts and laws to many simple and complex physical situations involving the motion of single particle, two particle, and many particle systems. For example, you will study the motion of cars on curved road, the moon or geostationary satellite orbiting the Earth and other planets in orbits around the sun, dumbbells, children riding giant wheels or merry-go-round, collisions of particles, etc. The subject matter of block 4 is harmonic oscillation, which is very common in nature. Example of oscillatory motions are an oscillating pendulum, vibrating string of a guitar or veena, atoms vibrating around their equilibrium position in a crystal lattice, our heartbeat, etc. A proper understanding of oscillatory motion is important for two reasons. Firstly, a large variety of mechanical as well as non-mechanical systems execute oscillatory motions. Secondly, and perhaps more importantly, a thorough understanding of oscillation is an essential background for the study of wave phenomena. We begin the block of discussing simple harmonic motion (SHM) and the effect of damping on a harmonic oscillator. Since oscillatory motions and the wave phenomenon are interconnected, we end our discussion on oscillations in block 4 with a brief introduction to wave phenomenon. One last word about how to study the course material. In block 1 of this course, you will learn the mathematics necessary to understand the contents of block 2, 3 and 4. To use mathematics effectively in applications, you need not just knowledge, but skill. Skill comes only through practice. For acquiring the necessary skill, you will need to work through the text and example and solve problems. So always study with a paper and pencil in hand. This is true for the remaining blocks as well. Physics, as you know, cannot be learned passively. You have to not only understand concepts but acquire the abilities of reasoning and problem solving. Work through all steps in the derivations given in the text yourself. The course has been designed with a large number of worked out examples along with SAQs and TQs. Don't just read through solved examples or answer to SAQs, self-assessment question and TQs, terminal question, given at the end of each unit. Try to do them yourself. In the course material, you will find many problems intended for drill and few challenging ones as well. Do not feel satisfied with your study until you can solve a reasonable number of these problems. Our best wishes are with you for happy problem solving and a good understanding of the course. We wish you success.